Okay, so now that we've been given a bit of an introduction to forces, what a force is, what a force does, it's time to start looking at one of the most important things that we talk about in dynamics, and those are Newton's laws of motion. We're just going to start with Newton's first law of motion, but the bulk of what we're going to actually be doing in this unit focuses on Newton's second law, but today we're just going to start with Newton's first law. And whenever we talk about Newton's first law, it's also sometimes referred to as the law of inertia. And this all comes about basically of the thought people had why things move. And a lot of people didn't really have great explanations of that just because they couldn't really tie in theory to what they were observing. And one of the big things is people didn't account for things like air resistance and friction. Now, eventually, Galileo came along, and Galileo said that every single object has a special property. And this property, we're going to call it inertia. And basically, just to kind of really simplify it, the inertia of an object, it's an object's property, it basically means its ability to resist acceleration. So an object with more inertia is going to resist changes acceleration more than something with less inertia. So like for example, me as a human being, like I'm a big guy, I'm about 100 kilo, maybe 110 kilos, I'm going to have more inertia than the chair I'm sitting on. The chair I'm sitting on, maybe like 10 kilos. What this means is because I have more mass, hence I have more inertia, you're going to require a much larger force or a larger acceleration to get me moving than that of the chair that I'm sitting in. Kind of the same thing. If you want to like kick a small little pebble on the ground versus like a large rock, one of them is going to need more force to move as opposed to the other. The big thing that we want to highlight though is inertia is not a force, it's just a property. You'll hear people talk about the force of inertia and stuff like that. Ignore those people, they are not correct. With that said, we want to start talking about Newton's first law. So Newton's first law says that an object will continue either being at rest or moving at constant velocity unless acted upon by an external non-zero net force. Now technically rest is implied with constant velocity because v equals 0 is certainly constant. The way we could phrase this mathematically is that if f net is 0, the change in the velocity is going to be 0, or we could say that the acceleration is 0. So Newton's first law is kind of basically, if we want to really simplify it, it's basically whatever an object's doing, unless if there's no external net force, it wants to continue doing exactly what it's doing. So there's two possibilities we could talk about here. If an object is at rest and there's no external force, there's no net force acting on it, it will remain at rest. It's very happy being at rest, it won't change. If the object is moving with some constant velocity, if there's a net force of 0 acting on it, or the net force acting on the object 0, it's going to continue to move at constant velocity. It's very happy doing what it's doing. The other important part with this is that if there are no external forces acting on an object, we're going to say that the object moves in a straight line. Because we talked about a little bit earlier that one of the things that a force can do is it can change the direction of the object. But if we're saying the net force on the object is 0, we can't have a change in direction, so the object is going to continue to move in a straight line. This point will become a bit more important later when we discuss circular motion, but again, I'm getting ahead of myself here. And yeah, if you want to change the motion of the object in any way, whether it's the speed or the direction, so essentially changing the velocity, you absolutely need to have a non-zero net force acting on that object. You would have seen this term, I've mentioned it a couple times, and you're going to see it crop up a lot in physics. You're going to see this term external forces. And you're going to hear it a lot in Physics 20, and you're going to hear it a lot in Physics 30. So these are forces that are not added to the system by an external agent, and we'd also say that they're forces that are not intrinsic to the universe. So the big thing is the force of gravity. You can't get rid of the force of gravity. It's always going to be there. So what we're going to say is that the force of gravity is not an external force. It's actually probably a better way of phrasing it, maybe like an internal force, and even then that's probably a little bit of a stretch. But gravity, force of gravity is not external. The common types of external forces that you can encounter in physics, things like air resistance, friction, applied forces, tension, those are considered external to the system. So if you don't have any of those forces acting on an object and the net force is 0, the object is going to continue happily doing what it was doing. So if it was at rest, it's going to stay at rest. If it was moving with constant velocity, it's going to continue to move at constant velocity.